So today, or this video, we're going to talk about what I call curve setting or sinusoidal curve setting. Sinusoidal is just a word that means that the curve is, you're going to use a sine or cosine curve to, a sine or cosine equation to fit the curve. So this is used when if we're trying to just take an equation of sine or cosine and graph it, or if we're looking at a sine or cosine curve and trying to write the equation for it. And this is very similar to what you may have learned in Pre-Cal 1, where the adding on the inside moves things right and left, multiplying on the inside stretches things horizontally, adding on the outside moves things up and down, and multiplying on the outside stretches things vertically. But with sinusoidal, with the trig functions, I think there's a better approach to look at all that stuff by looking at the different numbers that can be in an equation. And I've written a general form of a sine or cosine. This could be sine or cosine equation, and each one of those letters represent potential places where a number can be put in that'll change the shape of the graph. And one of the best ways to handle this is just to know what each one of those things do. So the amplitude is just the distance from the middle to the top, which of course would just be half the distance from the max to the minimum. So you could find this by going max minus minimum divided by 2. So that's amplitude. The vertical shift, of course, is just, as we've talked about before in Pre-Cal 1, is just how far the graph has been shifted up. But the thing about the sine curve is, or cosine curves, the vertical shift is always equal to the middle of the graph, because the middle is the only thing that's not being affected by amplitude. So you cannot look at the top or bottom of the graph to find out how it's been shifted, because the top or bottom is going to be affected by amplitude and shift. So we look at where the new middle of the graph is to find out what the vertical shift is. Frequency is equal to, in sine and cosine, it's always 2 pi divided by the period. So likewise, if I'm trying to find period from the frequency, that's going to be equal to 2 pi divided by the frequency. And that is not a W, it's an omega. It's a Greek letter for that stands for frequency. And then finally, phase shift is just that's a fancy way of saying the horizontal shift. So if we're looking at an equation that says y equals 2 sine of, let's say, 1/2 x plus 2, x plus pi over 2 plus 1. So if we wanted to draw a picture of that equation, or in other words, graph it, first thing I would do is just make a list. Let's see, the amplitude is 2, the vertical shift is 1, the frequency is 1/2, so what we really need is the period. The period is 2 pi divided by 1/2, which would be 4 pi, and the phase shift is pi over 2, and that would be pi over 2 to the left. So actually we probably should put a negative pi over 2 there, because remember on the inside the shift happens the opposite way of the number. So then if I wanted to graph this, I would draw my xy axes and put a 1, 2, 3 there, and a 1, 2, negative 2 there. And this would be like pi over 2, pi, 3 pi over 2, 2 pi, etc. Pi, 4 pi. So the period is 4 pi, which means it's going to go a full cycle. It's going to take 4 pi to go to full cycle. I'm getting ahead of myself. Let's go back to the vertical shift. So the vertical shift, remember, is the new middle. So what I like to do is put a little dotted line that shows me where the new middle is. Normally the middle of the graph is on the x-axis, but now we're saying the middle of the graph is at 1. And since the amplitude is the distance from the middle to the top, or the middle to the bottom, that means we're going to have a top out at 3. Because the middle is at 1, that means the top would be at 3, and the bottom would be at -1. So by putting these dotted lines, I've established where the top, middle, and bottom are, so I don't have to worry about them later, because now I want to focus on the period and the phase shift. So the period is 4 pi, which means it's going to take 4 pi to go from the beginning to the end of one cycle. And we know the sine starts its cycle. In other words, by start I mean on the y-axis. Starts on the y-axis at the middle of the graph. Because keep in mind that sine looks like this normally. Quick little sketch, right? So it starts at the middle, goes up to the top, back down to the middle halfway, down to the bottom, and then back up to the middle at the full cycle. So that's all going to happen between 0 and 4 pi right here. But then the phase shift says I got to move back pi over 2. So that means instead of starting right here in the middle, and I'll pick a different color here for a second, that means I'm going to actually start right there. Which means instead of ending at 4 pi, I'm going to end right here between 3 pi and 4 pi. So I know I have to start here at the middle, end here at the middle. Halfway, I'm also going to be at the middle. So halfway would be 1, 2, would be right about there, right? So I'm going to start at the middle here, hit the middle again, whoops, at 3 pi over 2, and then hit the middle again at what is that, 7 pi over 2. So then I got to go halfway between these two to get the top. So I should be hitting the top right there. I should be hitting the bottom right there. So now I'm just going to draw this beautiful sine curve. Whoops, I missed over here, didn't I? Show it more like that. Okay, and I'll be posting some more videos of doing a lot of examples of this, but the main thing is to understand how the amplitude, vertical shift, period, and phase shift affect the graph. And then knowing that this number is the amplitude, this number is the frequency which gives you the period, this number is the phase shift, and that number is the vertical shift, which gives you the new middle.